Hello, everybody, and welcome to IGTV. This is our InfoGuard editorial with William H. Murray. And Bill, you're going to be talking about access control today, huh?
Yep.
All right. So go ahead, take it away.
In the early days of the computer, security meant access control. We really relied on accountability, but we didn't talk about it much. We were worried about sharing expensive hardware while not sharing sensitive data. In large part because of the influence of DoD, we thought of access control mostly in terms of preserving confidentiality, read access, resisting leakage, less in terms of preserving integrity, write access, resisting contamination. Often, write access was simply given to a group by default. Of course, write access was much more useful for expanding one's privileges. We used to talk about the rule of least privilege, which provided that risk was minimized when users had access only to that data and those privileges that they needed to do their jobs. The idea was that the more people with access to data, the greater the probability that it would leak. Moreover, the fewer privileges and capabilities that a user had, the less chance that he would be able to expand them. Another way of stating the access for data was need to know, the language that the DoD security policy for access to classified data. One problem with enforcing such a policy was that often the controls were not sufficiently granular to map the access of the user to only that data that she needed. The data object that contained the data she needed might also contain other data. The assumption at the time was that the operating system would be the software relied upon to enforce the rules. However, the operating system could only control access to data objects that were defined to it. Often, this did not provide sufficient granularity of control. For example, the operating system might know about a file containing records, about customers, but only the database manager might know about the records themselves. A given user might need to know about only a subset of the records, that is, the rows in the database, while another user may need to know only about certain fields, columns within the database. Our object of control was usually a data object, that is, a file. Again, this was often not sufficiently granular. It was often better to be able to control a capability, that is, the privilege to access data only by means of a specific procedure, program, command, or transaction type. Another problem was that the more granular the controls, the greater the amount of work in administering them. This gave rise to abstractions such as groups and roles. Access to an object could be granted to a named group of users. The access could be granted to a user by joining him to a group that already existed, that already had access. Similarly, an administrator could define a role, for example, teller or loan officer. Simply by identifying the user with a role, he would get all and only the access required by a teller. In theory, a user could belong to many groups, but only one role. Roles were used to enforce segregation of duties. Unlike groups, where a user could enjoy simultaneously the privileges of groups to whom he had been joined, he could only exercise one role at a time. He might act in multiple roles, but only one at a time. All users might be employees, for example, for the purpose of doing self-administration. While this was a very useful concept, it was lost not only on the administrators, but also on the implementers of the controls. One might find that the concepts of groups and roles were used almost interchangeably. The more sophisticated, not to say complicated, the controls, the more special knowledge was required to operate them. This gave rise to specialized administrators who understood how to use the controls. However, this separated the decision about access from the implementation of it. It might be that only the manager really understood what access was appropriate and intended, but only the administrator understood the controls well enough to apply the decision. Much changed with the advent of the personal computer. Cheap computers led to a breakdown of central control. Cheap storage resulted in proliferation of, not to say gratuitous, copies of the data. We ended up needing to rely on physical control to keep the data from being lost with the device. While the personal computer did have primitive access controls, they were not reliable to control data access of the owner of the machine, or even somebody who had misappropriated the machine. Given sufficient time with your laptop, I'll find the data that's on there. Of course, cheap computers were followed by networking and then client-server applications. The application became the object of control, and user identification and authentication the primary, not to say the exclusive, control. In the 80s, Don Parker began to assert that need to share trumps need to know. For many enterprises, much of their information was public in any case. The value of some data went up with the number of people who acted on it rather than on the fewer who knew it. We saw this again after 9/11. Sharing increased, as did the number of individuals with clearances. The inevitable result was WikiLeaks. We now live in a world of the flat enterprise network. Essentially, everyone has addressability to most of the information in the enterprise from almost any device that they carry or that they choose. They enjoy such control over the devices that a simple error can compromise not only that device, but all those that are peer connected to it. This is the condition that leads to and is being exploited by insiders and the so-called advanced persistent threat. Moreover, a recent study by the Ponemon Institute for HP found that more than 50% of 5,500 IT workers polled reported that they had access to sensitive data that they did not need to do their jobs. A study by Cisco of the so-called digital natives, that is, college students and young professionals that came of age in a world of cheap computers and storage, found that 6 in 10 feel that security is not their responsibility, and that 7 in 10 frequently, not to say routinely, ignore IT policies. I remember complaining to my students at the Naval Postgraduate School that the school was blocking instant messaging and other social media in a futile attempt to resist leakage. My students offered to set me up with a proxy. When they did that, I realized that I already had one at home. These were my students, and I was teaching them security. It seems clear that we cannot rely upon them, or even me, for the security of sensitive data. All of this brings us back to access control and to the issue of classification and labeling. The implication is that we must make, record, and implement decisions about how sensitive data is, how it is to be used, and how it must be protected. We must enforce these decisions with rules and automated controls that resist copying and contamination and provide accountability. We must do so as close to the data as possible, where the controls are most specific to the data, most reliable, and most resistant to compromise. In many enterprises, this may require a new management system and perhaps even a new culture. It is up to us to articulate those systems and encourage that culture. It is for that that we are called professionals and are paid the big bucks. I hope that you all had a happy holiday, and I will see you in the new year.
Bill, thank you very much. I didn't mean to cut you off on the end there. Your season's tidings to everybody. I certainly appreciate it. All right. Have a great holiday yourself, and we'll see you in the new year.
Thank you very much.
Right.